In the previous video, we looked at how to optimize some of the virtual machine settings and some of the things we may want to consider doing in terms of the different devices that we can use for virtualization, depending on the operating system that we're supporting or depending on whether it's a boot disk or a data disk. What I'd like to talk about in this video is resource reservations and limits and how we can apply them to either guarantee a certain level of performance or ensure that a machine doesn't use excessive amounts of capacity beyond what we really intended for it to use, just because it has a lot of demand or something. I've already opened the virtual machine properties for W2K8R2-2. In this case, I've got a pretty low-end configuration assigned to it. I've got 1 gig of memory, I've got 1 CPU. Potentially, we can go and add to that, depending on what operating system we're running inside that virtual machine. We may be able to hot add memory and hot add CPUs. But in this case, we're never going to use more than 1 core, and we're never going to use more than 1 gig of RAM. Virtual machines will not use more than their declared resources. However, I may want to ensure that this small amount of memory I've set aside for it is always available. It is certainly possible that VMware will page almost all of this virtual machine out to disk if we have swap available. So we may want to prevent that from happening and guarantee that this meager amount of resources I'm providing to it are always going to be there no matter what's happening on the system. So if I go over to the resources, you'll see that under memory, I could just reserve all guest memory. And I can say in this case, I've said 1 gig and that's the 1 gig you're going to get. And that's an easy way to do it. But we can also go and say, well, I want to reserve a certain proportion of that. Maybe I want to keep 512 megs. And that means that in memory, in physical RAM, I'm always going to have 512 megs allocated to that virtual machine, no matter what. When this machine turns on, if there's not 512 megs of physical RAM available or can't be made available, this machine will not be able to be powered on. So we need to be a little careful. Often we're going to use oversubscription, and we're going to have more virtual resources declared than the actual physical resources in the host. Or maybe we're even going farther with this and we're looking at something like a DRS cluster. That's okay, but if we do that and then start trying to guarantee it, well, that's not going to be okay. For the meager amount of memory that I've given it, I don't probably need to steal a lot of it back. But if I wanted to, I could say, well, you know what? I don't really want you using more than 768 megs in this case. It may have been better to not give it that memory in the first place. If I set a limit here, the virtual machine thinks it has access to 1 gig of memory. I've set a limit here, but anything above this 768 meg boundary is going to go straight into the paging file for VMware. It may be useful, for example, maybe your application actually tests for the amount of memory that the machine thinks it has, and we need to say that it's got 4 gigs of memory, but I never actually want to give it 4 gigs of memory. I could do these sorts of limits. It's best if I just don't declare it, but if I wanted to change the declared amount of memory, I'd have to shut the virtual machine down, change it, and then bring it back up. And again, if my app doesn't like that, we could just tell it that it has basically 4 gigs of virtual memory available, and then start limiting it this way. We can also do the same thing for CPU, and we can dedicate an exact amount of CPU time or a limit. Now, one virtual CPU always runs on 1 physical core, or 1 logical core if we're using something like hyperthreading, and it will never go beyond that. If I have multiple virtual CPUs, then each one of those virtual CPUs have to run simultaneously, so we'll have to wait for a couple of cores to be available. But we can specify an exact amount of aggregate usage that we want here, even if it's slightly more than the capacity of 1 physical CPU, so long as I have 2 virtual CPUs to be able to do that. Now, all of these reservation and limit numbers can get a little tricky, and it can really be difficult to keep track of what you've allocated here and keep up with it and make sure that what you'd set 6 months ago is still appropriate and, all of those sorts of issues. So what we may want to do, instead of reserving and limiting resources this way, we may be better off using shares. When we use shares, the resources are basically available to everyone so long as there's no competition. Once we start to have a shortage of resources, then machines who have shares that are higher than the other machines will get a priority for that resource. If I have one virtual machine whose shares are set to normal for CPU and another who's set to high for CPU, that virtual machine will get twice as much priority to the CPU. Now, of course, as we expand out the number of virtual machines on our hosts, it could be a little difficult to actually, visualize exactly who's going to get what resources in any given time. But we can use resource pools to basically set these types of properties on groups of machines as well. And we're going to take a look at that in another video. So the shares can work well and can just basically allow us to set effectively a priority. We can also go in and use custom and start specifying some numbers here. Don't really think of this as any exact amount of megahertz or anything like that. just try to think of it in terms of a weighted average. So if we take this and we add it together with all the other virtual machines running on that host, or all the other virtual machines running in that resource pool or in that DRS cluster, those are the numbers that count. And if I've got one who's got a share of 1 and another who's got a share of 2, well, one's twice as much as the other, and that's all there is that we need to do. So we don't really have to worry about tying these numbers back to anything. But they're nice big round numbers, so we can, find little sweet spots and things in between if we need to. We're definitely better off in most cases to look at things like DRS and resource pools to do this on groups of machines. From a disk perspective, the options are a little different. We can't really guarantee disk performance because that's typically going to be done on a SAN, and that's going to be outside of our control. Now, if you're using Enterprise Edition and your SAN supports it, you may be able to get some level of quality of service on the SAN, but a typical VMware installation won't have that. So we can limit the amount of I/O that we generate, the number of IOs per second, and we can use shares, and that's pretty much all that we get. We can also go into the advanced CPU settings. We can specify whether or not we want to use hyperthreading, and typically we do. So it's a good idea to have this turned on in the BIOS, and then we shouldn't have any need to force certain behavior for hyperthreading, but I would not do that. You can also, and again, I wouldn't do this, specify exactly which physical CPUs this virtual machine will use. There's very little reason to do that, and that will actually block you from doing vMotion. So I definitely would not suggest it, but it is available if you're having trouble or testing something. So that gives us a little bit of an idea as to how we can use the reservations and limits, but we'll see more details of how all this works on a larger scale when we look at resource pools in an upcoming video.